Okay, we will wait one more minute to allow others to join, and then we'll start. Okay, I think we've slowed down in terms of the participants coming in, so why don't we go ahead and get started? And good afternoon to our esteemed colleagues in Israel, and good morning to our EPA staff and guests. Welcome to the second webinar on water quality. My name is Sally Gutierrez from the USEPA's Office of Research and Development. Today's presentation is on the portions of the Federal Clean Water Act that address best available technology and effluent limitation guidelines. This presentation is going to be a bit different from our first presentation that was very high level. This is really going to focus on a particular aspect of the Act. So it will be a little bit more detailed and more technical in nature. In terms of meeting logistics, we will again be recording the presentation, and the recording has already started. The first webinar recording has already been posted and is available on the POSI Global website, and I've placed the link to that web address in the chat, so if you'd like to copy that and have it at the ready, it has been posted. Please feel free to write your questions in English in the chat box, and should you have questions in Hebrew, please send them to the email or WhatsApp number listed in the chat for Phyllis Posey. We ask you to please mute your microphones unless you are speaking to help keep the webinar on track. But please feel free to post questions and pose questions as the presentation goes along. With that out of the way, it's my pleasure to introduce Mr. Timothy Buckley from our U.S. Embassy Israel Tel Aviv branch office to provide opening remarks. So please take it away, Mr. Buckley.
Thank you so much, Sally, and thank you for the invitation to be here today. It's very exciting. And on behalf of the U.S. Embassy in Jerusalem and those of us here in our embassy branch office in Tel Aviv, welcome to this, and thank you so much for taking the time to participate in this. I'm honored to be able to join in on this webinar. I was able to join as well and observe the previous one. It's a great initiative, and we're great. It pleases us to see the sides getting together. I'm a career foreign service officer, and I recently arrived in Israel in August to serve as our environment, science, technology, and health chief, and I'm based here in Tel Aviv. I've been a diplomat for 18 years, but I'm very excited to be part of this particular dynamic bilateral relationship with the state of Israel. Water is an incredibly important issue, both domestically in the United States and for our foreign policy abroad. As the Department of State highlighted on the occasion of World Water Day earlier this year, every country's health, prosperity, and security depends on reliable access to water. The USA is committed to building a more water-secure world, both abroad and through our actions at home. And in a broader sense, U.S. climate and environmental diplomacy aspires to realize economic growth, energy security, and a healthy planet. The well-being of the natural world affects millions of US jobs and the health of our people. And the Department of State works with partners, both back in Washington and here in Israel, to advance US interests on issues such as the climate crisis, fostering resilience, conserving nature, protecting water security, and reducing harmful pollutants. As a relative newcomer to the portfolio here in Israel, I'm deeply impressed by the strong and long-standing cooperation between our governments, especially between our Environmental Protection Agency and the Israel Ministry of Environmental Protection. And of course, we have many other representatives from other ministries and entities here today as well, which is a great example of a whole of government approach to address our issues and advance our agenda. Our embassy works closely with other Israeli ministries on a regular basis, and I'm glad to see so many here, including to discuss climate issues, water security, and also here locally we work on transboundary water issues. I know that the COVID pandemic disrupted so many of our plans, including for in-person engagements, but it's also great that you have been able to find and identify ways to continue communication and stay in touch, including through interactive online fora like we are in today. I hope that you'll be able to connect in person soon, for example, through the water reuse mission. And I hope to welcome some of you out here to Israel in 2022 and proceed with that engagement. We're very pleased. There's so many opportunities, and this is just the second of 5 to discuss the topic in depth. But we'll be very interested in the embassy to learn about the opportunities and challenges that emerge from your discussions and action steps that we can include and incorporate into the agenda of our daily work. Soon we'll also look forward to welcoming an embassy science fellow from the EPA to Israel, hopefully in the coming weeks, which is another example of the great collaboration between our countries. Israel is one of the world's leaders in water reuse, of course, recycling an impressive 85% of water for other uses, which I appreciate here as a day-to-day resident of Israel myself, and I'm confident that we in the United States can learn from the experience and best practices. This is especially true as climate change presents challenges to many communities in America and abroad in meeting their long-term water needs. In return, there's a lot of expertise on the US side that will be beneficial, and I look forward to hearing some of that today in our discussion. And finally, it's important to note that the work that you do is closely connected to the global efforts to respond to the climate crisis. As we speak, many of our colleagues are in Glasgow at the COP26 conference, where water is taking center stage. The UN is predicting a 40% shortfall in freshwater resources by 2030. Both the US and Israel have very large delegations reflecting our growing climate ambitions and strong commitment to addressing climate issues, including on water. And finally, Secretary of State Blinken recognized on the occasion of World Water Day not only the importance of protecting an essential resource, but he also recognized and acknowledged those working to ensure safe access to water for all. And that includes all of you. And I'm delighted to see more than 50 of you online, and I thank you for your day-to-day efforts, and I look forward to a fruitful discussion. Thank you very much.
Thank you, Mr. Buckley. We are also honored today to be joined by Mr. Rob Wood, who is serving as the Deputy Director of the Office of Science and Technology at USEPA and has been responsible for administering the Effluent Guidelines program for many years. And Colleen Flaherty, also from the Office of Science and Technology, and they will be assisting our speaker with many of the technical questions as they come up today. Now I'd like to introduce our speaker, Mary Ellen Levine. Mary Ellen serves as the Assistant General Counsel for Technology and Wet Weather Flow in the Water Law Office in US EPA's Office of General Counsel. She leads attorneys handling rulemaking, counseling, and litigation under the Clean Water Act, including technology-based rules for major categories of industrial sources, such as steam electric power plants, oil and gas facilities, and sewage treatment plants. Before joining EPA, she worked as an associate at Mintz, Levin, Cohen, Ferris, Glovsky, and Popeo, PC in Washington, D.C. She received her law degree with honors from George Washington University and her A.B. cum laude from Harvard. With that, I'll welcome our speaker, Mary Ellen Levine. Welcome, Mary Ellen.
Thank you so much, Sally, and thank you to my colleagues from EPA who are going to help me here in presenting this material on best available technology. As Sally said, I'm a lawyer in our Office of General Counsel, and I assist Rob Wood, who is also on the call. He is the person who runs the program that establishes these standards. So I am one of his team of lawyers who work with him on these regulations. And I encourage you, I'm going to open the chat so that I can sort of see if there are questions coming, but I look to my EPA colleagues to help me see when people have questions, and I encourage you to ask them. There's a lot we can talk about here that is not on the slides. So I am so honored to speak with you all today. This is really a great honor to speak with you, and thank you for all of the work that you are doing to protect the resources that are so precious to our world. Today we're going to discuss the part of the Clean Water Act that relates to best available technology. And we're going to talk about environmental management in the United States broadly. We're going to talk about how best available technology is part of the environmental management system. We're going to discuss who should set BAT standards. And one moment, I'm just going to make my screen a little bigger. Thank you. Who should set BAT standards and rules? What sources and categories should be regulated? What pollutants are regulated? What criteria we consider when determining best available technology? What are the limits of BAT? And what implementation and enforcement issues should be considered when setting these standards? Environmental management in the United States really is a continuous cycle of development and improvement with the goal of protecting human health and the environment. It's a complicated system because there are many different layers of environmental regulation in the United States. There are national, regional, or state and local regulations, along with voluntary programs and market-based programs. And all of these can be effective in achieving significant pollutant reductions. Regional and state cooperation is critical for controlling pollution that affects multiple cities and multiple states. So we have regional efforts as well that entail cooperation from disparate states with disparate interests. And I am getting, Sally, are you able to admit people? Because I'm getting a request for admission.
Yes, you don't have to worry about it, Mary Ellen.
Okay, thank you.
We're getting everyone put in. Okay. I do see a
hand.
Avi has his hand up. Go ahead, Avi.
By mistake, sorry.
Okay, thank you.
Okay. The other thing I wanted to mention was providing information to the public is really critical, that the public really plays a key role in the establishment and the implementation of standards. This next graphic just shows, this is a very common kind of schematic that we use in the water program for many aspects of the water program and is also applicable to BAT standards. And if we start in the upper right-hand corner, what the Effluent Guidelines program does is they look at existing discharges and amounts of remaining existing discharges. Then they also consider, when they look at the quantities coming from various sources, they look at available technologies that might be might have been developed since the last time we had developed these standards to see whether or not there were promising technologies to address these remaining discharges. Then we make a decision of whether we're going to revise the existing standards. And if we choose to revise the existing standards to make them more stringent, we propose them for public comment. And then once we establish them, we go through an implementation phase. And this cycle just continues and continues under the Clean Water Act. Public participation is really important for the environmental management system in the United States. It is really important that we hear from the public and environmental groups. I think that they sometimes push us forward and help us set our priorities. At the same time, the regulated industry also plays a critical role. They provide information to EPA for rule development. They comment on regulations. They're responsible for demonstrating compliance on an ongoing basis. And under the Clean Water Act, we really have a regime of the industry self-reporting. And as a lawyer, I can tell you that both the public and the industry basically challenge every single thing that we do. And so as a lawyer, as we're doing these rulemakings, we try to consider every single adverse comment and critique of what we're doing and try to address that before we issue the regulations. So now we're going to talk more specifically about best available technology. And I feel very proud to have worked on these rules for almost 30 years now. These rules really make a difference on the ground in our waters. We know that BAT rules apply to 40,000 direct dischargers, 129,000 dischargers to sewage treatment plants, which our law calls publicly owned treatment works, and tens of thousands of active construction sites. And at last count, and I think this is probably an underestimate because we've done some rules since I think this was last counted, but around 700 billion pounds of pollutant discharges are reduced each year. These rules really make people change what they're doing on the ground. These rules also foster innovation and development of new technologies. We'll talk a little bit more about how that happens. They are easier to implement. But then on the downside, they do not by themselves guarantee a particular level of public health or environmental protection. And we'll be explaining that in detail further in the presentation. So the key two pieces of information that we gather to establish these standards are the engineering information about treatment technologies and their performance, and then based on the cost, the economic information about the facilities that would be regulated and how this is going to affect their bottom line. So what can the industry afford? Now I want to step out of BAT for a moment to help you understand how BAT fits into the Clean Water Act. Under the United States Clean Water Act, there are two major approaches to protecting water quality. The first is the technology-based approach, and that's what we're discussing today. And the second is the water quality-based approach. So in essence, we do as much pollutant reduction as we can through the technology-based approach, but where that is insufficient to meet the water quality goals, then we have a different part of the statute that allows us to place water quality-based effluent limitations on discharges. Under our statute, the states have the primary role for protecting the nation's waters, which might be surprising, but that's in Section 101 of the Clean Water Act. And under the Clean Water Act, states designate uses for their water bodies, which are the objectives. What is the water to be used for? For example, recreational swimming, which we call primary contact recreation, or secondary contact boating, or fishing. Fishing would entail being able to eat the fish that you catch, aquatic life protection, human health protection. And then the Clean Water Act requires states to develop criteria that are necessary to protect those uses. And the criteria are generally numeric for constituents, and we have issued criteria recommendations for many pollutants, but not all, or they can be narrative. So the BAT rules are the first step. They set the floor. Basically, Congress said when they adopted this law in 1972 that the water quality approach of what is necessary to protect the water, everybody is pointing fingers at everybody else. So we're going to just put a stop on that for a moment, and we are going to say to EPA, you figure out what technology can achieve and what the industries can afford, and require that as a floor. And then where that technology-based regime is insufficient to protect water quality, then you can impose more stringent limits to protect water quality. And I just have a kind of funny slide here. So I just wanted to get this across because this really basic concept sometimes gets mixed up. So it's first technology. If that's insufficient, then more stringent standards to protect water quality. So today we're just talking really about the first step. And the other thing I needed to kind of talk to you about, just to ground you, is the Clean Water Act has a different regulatory regime for indirect versus direct discharge. Indirect discharge are people who are sending their wastewater to a sewage treatment plant, a publicly owned treatment works in our statute. And we do not have a permit program with respect to those discharges. The sewage treatment plant can issue a document to its customers to say, you cannot send me more than this amount of pollution. And we call those local limits, and they are federally enforceable, but it is not a Clean Water Act enforcement program. When we set these national rules for BAT, for the indirect dischargers, they are directly enforceable. So as soon as they are promulgated in our law, then they apply to anyone sending their wastewater, who, if they're in the applicable rule, if they're the industry regulated, they apply directly to those dischargers. Then direct dischargers are people who are directly discharging, not through a publicly owned treatment works. They're directly discharging to a water of the United States. And those dischargers receive Clean Water Act permits to authorize their discharges. And those permits are required to implement these BAT rules. Do people have questions about any of that? And then I just wanted to talk for a second about what is the technology requirement for those publicly owned treatment works. It is not BAT. The Clean Water Act gives publicly owned treatment works a different technology framework, which is based on secondary treatment. On these slides, I quoted the different sections of the Act. So it talks about effluent limitations based on secondary treatment. And I see a hand up.
Yeah, thank you. I'd like to ask a question about the best available technology.
Sure.
Since it's a economic standard, I'd say. What's the breaking point exactly? Because I assume contaminating water in Alaska is not as severe as contaminating them in California, in regards to the economic effect.
Right. And we will be discussing this further, but I'm happy to answer this now. The Clean Water Act is very vague about what is the breaking point. And unlike other laws, it doesn't tell us what the breaking point is. It talks about economic achievability, and there have been 40 years of case law, a precedent. We have a precedent, the United States legal system is one of precedent, saying that best available technology economically achievable means what the point source category can reasonably afford. Traditionally, we have looked at facility closure and job losses. We've looked at, in one of the rules I worked on, pulp and paper, we looked at a bankruptcy when it was going to result in job losses, a company moving to another, taking its operations abroad. And early on in the program, the economic impacts that we found to be reasonable and acceptable were actually quite severe. I would say over the decades, there is more reticence to impose economic impact on the regulated industries, but it usually the rules don't affect that many sites, such that it is very often, I would say in the last 25 years I've worked on this, where when we present options, there aren't very many, there aren't like maybe any closures. There might be, anytime you increase the cost curve, you're going to reduce the supply curve. And so we inform the administrator of those impacts, and usually they're not that great. I will also say that over the years, the administrator's not happy when I answer that question, that the administrator has flexibility. They don't want the flexibility. Because then, that makes that a harder decision. So in the early cases basically allow us to impose these BAT rules that have what today would be considered pretty serious impacts. But usually in the last, I would say 25 years, we haven't been imposing rules that have hugely serious impacts. We usually are able to quantify it and be able to describe how we affect the supply by increasing the cost. And then we usually determine that that amount is affordable. So I know that's probably not a completely satisfactory answer, but I've been doing this for 30 years, and that's really the way it works in this statute. So I just, getting back to secondary treatment, I just wanted to pause for just to let you know that for publicly owned treatment works, they are to have effluent limitations based on secondary treatment. And the legislative history talks about secondary treatment relating to biological treatment and removal of biological oxygen demand and total suspended solids. And the 1972 Act required, but then Congress later repealed, advanced treatment for POTWs. So one question, like a legal question that comes up, is can we revise what secondary treatment is? And you'll see in this second provision, it talks about how the administrator must publish within 60 days and from time to time thereafter, talk about the degree of effluent reduction attainable through the application of secondary treatment. So that language suggests that there could be some revision. The question I think that is unresolved is could that revision be beyond what's achieved by biological treatment? I will say that these rules have not been revised since, I think, 1981. At least it was in the 1980s. That's a long time. So when you sewage treatment plants in the United States, the real regulation of nutrients comes because of that second part of the Clean Water Act, where the technology basis is insufficient to protect water quality. Additional regulations additional effluent limitations can be imposed. So major sewage treatment plants in the United States do have regulations beyond that secondary treatment regulation, but those are based on water quality. So I know there were some questions about what sewage treatment plants were subject to, so I wanted to include those slides. So I now have a guest thing overtaking my slide, so I can't move it, but
working on it. Okay.
To those on the call, I am actually sight impaired. I'm blind in one eye, and I have a problem in my other eye. It was not the case when I started at EPA many years ago, but it does make me hard. It makes it a little difficult to read my slides. BAT is important in our environmental reduction program. We get certain reductions that we know are going to occur, and they can be helped to meet water quality goals, but they get us a certain further step toward our water quality goals, but they don't by themselves necessarily guarantee that we'll meet our water quality goals. And they need periodic reevaluation. And the last bullet is important, and I'm sure Rob Wood can speak to this, is they take a lot of time and work and effort to develop up front, because anyone in the United States who's affected by the regulation can challenge the regulation in court. And so this program works very hard to address all arguments that come from us from any sector. And so it's a very hard data resource intensive process up front, but then we basically, what we gain from that is it really is a much more streamlined implementation process on the back end than water quality based effluent limitation, which is very much site specific and case by case. So BAT rules are, let me just try to omit this guess so I can see my slide. BAT rules are much more implementable because we don't have to have like a case site specific battle of what is necessary to protect the particular water. And in the water quality arena, there are many exceptions to meeting water quality based effluent limits. There's provision for variances, there's provision for mixing zones, there's provision for compliance schedules. And while there are certain exceptions to these technology based rules, they are more objective. And so therefore, this is an easier part of our statute to implement. So we look to many different factors when we're establishing BAT rules. They can be based on pollution control technology achieved by sources in the category or even other categories. So if we know a certain wastewater treatment technology works for pesticide manufacturers and could be used for canning manufacturers, we could take the technology from one sector and apply it to the other point source category. We have to consider, as we've discussed a little bit, whether the cost is reasonable for the industry as a whole. And to me as a lawyer, I'm often suggesting to my clients, what percentage of the sector is already using the technology? Because the higher that percentage is, I think it's just easier for a court to say, well, that looks like best available technology to me. And not on the slides, but there is case law that best available technology can be based on one facility. It can be based on a pilot project, that it is to be a beacon to show what is possible. Because of the economic costs of maybe what one facility is doing, and also the concern that what one facility is doing isn't representative of what could be achieved by others, we often don't select our best available technology based on one facility or a pilot project. But in the derivation of the numeric limits, where we look at what's the influent and the effluent, I would say that we usually don't have data from that many facilities. And so we basically, I would say that many of the limits are actually derived based on actual effluent reduction data from a limited number of facilities. And we also consider the environmental impacts of using the pollution control technology. So if the wastewater technology causes a solid waste disposal problem, or a lot of air emissions, or has an energy penalty, it might actually cause, for example, certain, like in the power world, if it were to cause certain peaking plants to not stay in business because of the cost of the rule, and therefore there might be an energy reliability issue in some parts of the country, we could consider that to back off on what is the most pollutant reducing technology. And we also inform, but don't make our decision based on this as a fulcrum, but we inform ourselves of the cost effectiveness of control technologies. So if we are looking at 5 technologies, but 3 of them cost more and reduce less, they kind of get eliminated from the analysis early on. So who sets BAT? In the United States, it's the National Administrative Agency, USEPA, and states can be more stringent under the Clean Water Act, but where EPA has spoken in the BAT world, where we have established BAT and addressed BAT, that does occupy the field for purposes of the technology-based requirement for the Clean Water Act. So for example, if the state of Iowa chose to do something more stringent than our BAT rule, that requirement would only be enforceable as a matter of Iowa law. It would not be the Clean Water Act federal law. And in terms of how permitting works, where we haven't established a national standard, and this happens more than you would realize. We have, I think, 59 sectors regulated, But even within those rules, sometimes for the smaller facilities, we say that the national rule doesn't necessarily apply to a smaller facility. There may be thresholds in those regulations. So where the national rule doesn't apply, the Clean Water Act requires BAT to be imposed on a best professional judgment basis. And that's a little bit difficult. It's a little bit like putting a square peg into a round hole, because one permit writer in one state has to theoretically think about what is best available technology, considering the whole point source category, when that person may actually only really have information about that particular facility. That said, our effluent guidelines program, and Rob Wood can speak to this, has put, I think, that the development documents for all of the national regulations online, so that engineers can look at the wastewater treatment technology and the considerations, and that is a great resource for the state permit writers when they are doing this work. What sources are regulated? And I just wanted to take a moment to say that there are two different kinds of sources under the Clean Water Act regime: new sources and existing sources. And they're actually not treated that differently in terms of the factors we consider for establishing best available technology, except for in the economic realm. So we look at what, for existing sources, they can reasonably bear for the point source category as a whole. But for new sources, we don't really have that. So we do something called a barrier to entry analysis. So we evaluate whether the cost of the regulations are really going to cause a problem for a new source to get up and running. Many people make huge distinctions between new source and existing source, thinking that new source should be pushing much further than existing source, but the statute really doesn't have different factors. The legislative history indicates, and I agree, that the cost may well be lower for new sources because they don't have retrofit costs, and therefore they might be able to afford more. But it is more often than not that the best available technology for existing sources and new sources is the same. Sometimes it's more stringent for the new source, where that retrofit cost is big, and we do think that there's some technology that a new source could afford. This is just illustrative, this next slide, of what category, how do we identify source categories for regulation. There are many factors that go into this. We can find sources that are individually responsible for a lot of remaining pollution. The next bullet is more what we really do, is we do have good information about what permits require. And so our engineering office looks at what point source categories are discharging the most pollution still, even after being regulated. And then we also look to where new technologies have evolved since the last time we established best available technology. And finally, and importantly, sometimes there is a category, and we'll talk about an example below, where a new waste stream has developed in the industry since the last time we issued a best available technology rule. What pollutants are regulated? There are three kinds of pollutants in the Clean Water Act. There's toxic pollutants, conventional pollutants, and non-conventional pollutants. And toxic pollutants are a list of 65 families of pollutants established in our law, and which were later identified as 126 pollutants called the priority pollutants, but those are really synonyms. And also, so those are regulated at the BAT level. And non-conventional pollutants are things that are neither toxic nor conventional. And an important non-conventional pollutant would be anything having to do with nutrients. Nitrogen, ammonia is not listed as a toxic pollutant and qualifies as a non-conventional pollutant. So it's regulated at the BAT level. We have not amended the list of toxic pollutants. There's been some conversation about whether we should do that, but it's a fairly arduous process. Conventional pollutants are regulated at a best conventional level of control, which is a harder test to meet. So the slide describes it as a lower level of control, because it is very, very rare that a BCT level of control is adopted that's more stringent than the very first controls we established in the early days of the Clean Water Act. What we do is when we're studying an industry, we don't do a rule that has 126 parameters. If you look at our Code of Federal Regulation, what our engineers do is they look at pollutants that can be measured and treated by the pollution control technology that they're interested in. And we pick a subset of pollutants to represent the full suite of pollutants that would be controlled. So a regulation might regulate several metals, and then it would be representative of either all of the toxic pollutants in the waste stream or all of the metals. So we pick surrogate pollutants to represent the entire waste stream. And it's usually based on what analytical methods we have. And so we obviously need to use pollutants for which we have analytical methods where we feel very sure of what we're able to measure in the influent for the control technology and what the control technology actually achieves. We call those things, I think, pollutants of concern, which is not my favorite because it has a risk connotation, but it's really just the regulated pollutants, and we regulate a subset of all the pollutants from the waste stream. And then we say that if we are controlling those pollutants, you're controlling the rest of the pollutants. So I think I've alluded to the kind of the factors, and we're going to talk about this a little bit more in depth, but it's important to clarify what factors we must consider under the statute, what we have the discretion to consider, and what shouldn't be considered. So we look at the effectiveness of the control technology, technological availability, and the pollutant limits actually achieved by sources in the source category. And there is a lot of work that goes into that because industry often argues that our limits are not representative of the normal variability at a well-operated system. And our limits are designed to actually account for the normal variability at a well-operated system. On the economic side, we look at the cost of compliance, affordability to the industry as a whole that we've already covered in a question. Then we look at other environmental impacts, including energy impacts, and the statute says other factors as the administrator deems appropriate. A recent case in the Court of Appeals of the Fifth Circuit held that other factors does not mean we can upend really the framework, the statutory framework for BAT. So it is not an exception that can swallow the rule. So the next slide just lists these very important statutory factors: technologically available, economically achievable, acceptable non-water quality environmental impacts, other factors the administrator deems appropriate. This is right out of our statute. And importantly, it's not water quality impacts or a cost benefit analysis. Other statutes in the United States are cost benefit driven, such as our pesticide law. Parts of our Toxic Substances Control Act are cost benefit. This is not a cost benefit statute. An earlier level of control that's really been superseded by BAT did call for limited cost benefit balancing, but best available technology really just does consider the costs and economic achievability, which is really a concept of affordability as opposed to weighing social costs with social benefits. We do weigh social costs and benefits in the United States in all of our rules as per the Office of Management and Budget, the President's Office, wanting to look at what do you get for what you're requiring for rules, an executive order, but it is not a statutory factor, but it's additional work that we have to do. So I was asked to provide a more specific example, and if you were to Google a steam electric power plant image, you'll probably get this schematic that our client developed years ago. I think we started working on steam electric. We did a detailed study in 2009. We issued a rule in 2015. We revised that rule in 2020, and we are now looking at revising that rule again in this administration. But I wanted to talk to you about the specific steps for doing a rule. And you'll see here, these are the various waste streams at the a schematic of the waste streams at a steam electric power plant. You'll see the first waste stream is called flue gas desulfurization wastewater, and this is wastewater that occurs as part of the scrubber to prevent air pollution, but then it creates a new water pollution source. And so our old rules, which were from 1982, did not have really a requirement for FGD wastewater. Technically, it was subsumed, I think, under low volume waste, but it isn't really low volume waste anymore. And we also regulated fly ash, bottom ash, the leachate from the landfill at the facility, sluice mercury control, waste, and gasification process discharges. So we've done this now twice, and we're about to do it for a third time. So I just put down like the various steps, and we can take questions if you want. And we've got Rob Wood on the call to really discuss the details of all these analyses. But the first thing that the engineers do is they study the best pollution control technologies and processes used by the particular industry. They do site visits. We conduct surveys, which we have to do through rulemaking. And we try to find out what the facilities have in place. If we really have the time to do the whole rulemaking detailed study, we sometimes send a survey to either all of the facilities in the sector or a subset. And what the program has done in years past is they sort of categorize every single facility and kind of put it in a box. And then that's a type of facility. And then they model what's going on for everybody who looks like that one in terms of costs and engineering aspects. And then they use that to develop their cost analysis for the industry as a whole. Sometimes we don't have the time to do that detailed survey. That takes time because we have to go through a rulemaking process essentially to get the survey approved. And then, of course, when you send something like this out, it's not like it can be answered overnight, and it's not like the results of it can be assessed overnight. So you can imagine this is why it takes a long time to do these rules sometimes if we want to really understand what's going on everywhere. So sometimes we do something less. We look at a subset, just a handful of facilities, and we talk to trade associations to better understand. But we try to understand what pollution control technologies they are using, and we look at its performance, and we look at its costs. We also talk to vendors about the cost information, so we try to get any information we can. Some of the sources of information are proprietary, and so that entails a little bit more work also to get a handle of what that information shows. Then based on the costs, we evaluate the economic impacts on the industry of the candidate technology. And the AIR program has developed a model that they've used, that we used in steam electric, to evaluate what the production impacts are of the additional costs of a regulation. And so we've used that model. And doing this work is also really hard because it entails getting confidential financial information from the industry and then protecting that information and then having to evaluate it in a way that's publicly accessible without divulging the confidential information. So it's a bit of a challenge. And I see hands. Hands are raised.
Yeah, Mary Ellen. I have my hand up, Mary Ellen. This is Rob
Sure,
Wood. Hi,
sure.
everybody. And I just, this is just a sort of point of order, is that I actually have to leave this meeting at about 10. I can probably cheat a couple minutes past 10, but I've got my own meeting that I need to chair. So if you have questions for me, or if there's anything you want me to address, Mary Ellen, I've got that time constraint.
And Rob is the division director, the senior executive service manager for this program. So if anyone has any really technical questions, I'd ask him, not me, the lawyer.
This is Phyllis. I have a question that's not necessarily technical per se. But just in terms of an overall program, I mean, the years that you've been with the program, obviously many, how do you feel about the level of success you've had in advancing technologies that weren't available 10 years ago, for example?
Mary Ellen, you want me to take a shot at that?
Absolutely.
I think, first of all, I would say that I think that the design of the best available technology principle and the framework in which it's implemented, which is in the statute in the Clean Water Act, has been extremely successful. So I feel good about it. And I can give you sort of a couple of reasons why. Go back to that 700 billion pounds of pollutants eliminated. That's a hard actual calculation to do because that's from the inception of the program in 1972 all the way till now. And what we're basically saying there is, all other things being equal, if this best available technology program had not existed over from the mid 70s, really, when it got a lot of traction and we were really working at it, getting it implemented. And now there's about 700 billion pounds of pollutants, mainly toxic pollutants, that would be going out from industrial dischargers into waters of the U.S. On an annual basis through industrial point sources. Now, that's really an estimate, but I think it is a good indication of the success of the program, because we can actually, that's a reasonable estimate. Of course, there's a lot of other things at work, which are industry and forms of production come and go. And I think, sort of fast forwarding to now, Mary Ellen was just talking about the steam electric power generation point source category and our efforts to regulate that. And I think that what I have observed is that we began working on that that rulemaking in I guess about 2011, 2012, established a rule in 2015 where the best technology that we evaluated at that point was something called evaporation and crystallization for the flue gas desulfurization wastewater. And we didn't actually establish that as the best available technology in the 2015 rule because it was judged by agency leadership to be too expensive, too much impact on the industry. So so you fast forward to now, and what's happened in that industry? Well, a few things. Number one, there's been a lot of innovation in treating the flue gas desulfurization technology waste stream. And I'll quote Gina McCarthy, who I think you all know, or hopefully know who Gina McCarthy is, who was the administrator of EPA at the time of the 2015 rule. And she said, it's been my experience over and over again that if you set limits for the industry, they will end up performing better than what those limits are. And I think that's a testament to the innovation that happens because when we set technology-based limits, we're doing it based on a technology that we've evaluated. But we're really saying, we're not telling the industry that they have to use that technology. What we're telling them is that they have to meet limits that technology can achieve. And what will happen, just you can count on it, industry by industry by industry, they're going to try to find cheaper, faster, better ways to meet those limits. Case in point is with the steam electric power generation industry. There's a technology that we looked at very carefully for the 2020 rule and are still looking at very carefully for the next iteration of this rulemaking, and that's called membrane technology. I'm sure a lot of you are familiar with that because it's applied in a lot of different industries for a lot of different purposes. Drinking water treatment, anything that has a high total dissolved solids content. And membrane technology is being used internationally. There's some plants in China that are using it. The vendors are advancing the technology, and basically It's a technology that we didn't even really consider. And that was only in 2015. So it's front and center now. And I think it's largely due to the innovation. And I, again, would just say that the pressure and the incentive that's created on the industry by EPA taking a good hard look at what the treatment technologies are, industry category by industry category and across industry categories, that creates a powerful incentive, in my opinion, for industries to innovate on that technology. So hopefully that helps.
Yeah, that really does. I'm seeing some questions in the chat box. So Mary Ellen, Robert, do you want to kind of address them? Why don't we start from the beginning? Do you refer to technologies or techniques? It sounds like what you were saying earlier is that you generally talk about limits. So if you could just explain.
So what we do is we look at the various technology, and the slides aren't up, but that's okay. We can put them up if we need them at the end. Someone took control. We look at various technologies, and the rule is based on a technology or a suite of technology or management practices. And then we establish the limits that suite or one technology can meet. So let's just say machine X achieves 10 parts per million. Then the industry can do whatever they want. They can use any technology they want as long as they meet the 10 parts per million. And guess what? People are smart and innovative, and they find a cheaper way. That's what Rob was saying. They find a cheaper way to meet that 10. And so in that regard, these regulations have been technology forcing. People find a better way, a cheaper way to meet the limits. But when we establish the limits, we have to show that the number is achievable by a well-operated facility, accounting for the normal. There's variability even at a well-operated facility that is static. And these rules, they range from things that look very homogeneous to, say, airports and airport de-icing, which looks very different in various airports across the United States. So we have, whatever limit we establish has to be achievable by a properly operated, well-operated facility. And even that facility has some variability in its performance. So the number reflects that variability, and then people can work to find a different, better way, which they have. I've always dreamed of having a retrospective cost analysis of this program as compared to how much cost we owned and said we were causing the industry, because I suspect it's lower significantly, actually, if we were able to do that. But we don't have the resources to do that study, but it would fascinate me.
There's so many good questions here in the chat.
Yeah.
I don't know how you want to do this, Sally. I'm going to jump in about 5 minutes here, but let's see.
Pick your favorite, Rob, and then we'll try to work through the others.
And I saw I can handle the pre-treatment indirect versus direct after you leave, Rob.
Okay, good. And maybe also, where are the BAT lists published? I think that deserves a little bit of unpacking, and then reference to the Code of Federal Regulations, and also our website, because that information is all much more easily accessible now electronically than it has been ever, really. Let's see.
If you were to Google EPA effluent guidelines, you will wind up on Rob Wood's landing page.
Yeah.
And there, I believe you even have the development documents publicly online.
I can't guarantee that they're 100% there, but we've been working hard the last couple of years to have all of those PDF'd and digitally available through the website. What you'll see there basically is a summary of 59 industrial categories and about 400 subcategories within those 59 or across those 59. And more information than you probably ever wanted about what led to the limits that are established and the pollutants for which pollutants and why. It is a lot of information, but it is there, and there are points of contact for every industrial category. So if you have a question or a specific, problem that you're trying to solve in that, relevant to that industrial category, there you can reach out to my staff, whose contact information is there.
And in terms of the regulatory site and the Code of Federal Regulations, it's 40 CFR Part 400, and then you will have, starting at Part 400, 59 categories of effluent guidelines, regulations.
I'm going to try to take a stab at this question. There were a couple, or another one that was related to it too, but it's Daniel Sharon regarding the power plant. Do you refer to the effluents from industrial services such as water treatment as a source of pollutants? Short answer is yes. The schematic that Mary Ellen showed of it's really a composite of what a typical coal-fired power plant would looks like, and what the different waste streams are. Not everyone's going to have all of those waste streams, and some will have more boilers or fewer boilers, but all of those waste streams that are shown on that are well, I guess the whole facility is considered a source. Each of those waste streams is really dealt with individually as a source, and some of those plants discharge directly to surface waters, which is what's shown in that slide. Others discharge to publicly owned treatment works, and Mary Ellen used that term a few times. Publicly owned treatment work. It's essentially a domestic sewage treatment plant that's publicly owned that receives that can receive industrial waste as well. And so, in the power plant scheme, there are both what we have set for and are continuing to work on actually in the steam electric power generation point source category is both limits on the sources that are direct discharges and limits on the waste streams that are indirect, that are going to publicly owned treatment work. So we're doing both in that, and that's, the technical term is effluent limitations, guidelines, and standards. The effluent limitations guidelines is referring to the direct discharge, and the standards part of it is referring to the indirect discharge or pre-treatment standards that we're setting. And then one other point is that there is this idea of new sources that Mary Ellen touched on and existing sources. Sometimes there's a differentiation in the effluent guidelines and standards for, where we have one level of treatment, which is for new sources, and that's new source performance standards. And so that's and then there's the standards for existing sources, and they might be different because what a facility can economically has to do before it's designed and up and running may be less of a burden because it can design the treatment into it than if the facility is existing and they're coming back and having to kind of retrofit in order to meet a standard. And then the last point that I'll make on the and again, using coal-fired power plants or steam electric, if you will, as the example, is on this concept of new sources versus existing sources. There are no new coal-fired power plants in the United States. So there's the new source performance standards part of the of that effluent guideline. While it's on the books and technically applies, it's practically not needed or used at this point because coal is being phased out, and that's just another trend that we have to account for when we're doing effluent guidelines. So hopefully that helped answer some of that some of those questions about sources.
Rob, there is a question about whether, do you refer to the BAT of the EU Industry Emissions Directive?
I think our engineers do. Our engineers do look at requirements in other countries, and I remember going to extreme lengths to be able to get our project officer on steam electric to see an evaporation facility in Italy. We do have resource limitations in this program that are our challenge in terms of international travel, but certainly in reviewing literature, the engineers do look at international requirements and the performance in other countries, absolutely. To the extent we don't do it, I would say it's because of resources, not because we don't view it as relevant. Legally, we would view it as something to inform ourselves of to the best of our ability.
There's a question on, have you had instances where the BAT requirement was perceived as hindering or slowing down the adoption of innovations?
I would say absolutely not. The critique of the best available technology program is that, and this is a historic critique, is it's regulation for regulation's sake, because it's done without respect to weighing costs and benefits. So scholars and philosophers who think you should weigh costs and benefits, which I think of as a utilitarian approach, think that this section of the statute maybe requires costs that don't have commensurate benefits. We don't have to prove the benefits. That's why this section of the Clean Water Act is achieved so much, because there is a lot of difficulty in justifying and improving, because everyone in water says it's not me, it's not me. The sewage treatment plants say it's ag. Ag says it's the sewage treatment plants. We all know stormwater runoff it's all of us. And so this section of the statute doesn't require a level of justification to regulate. So the main critique is really it's regulation for regulation's sake. And that's why I've always dreamed of a retrospective cost analysis, because I suspect the cost, like anecdotally on the rules I've worked on, I've known that technologies have been developed that were much less costly, to the point of really not costly at all. And I wish that we had known that at the time when we were trying to defend the rules. So anyway, it's not so much that it harms technology. And in fact, I think it fosters technologies that are cheaper than the one we identified as the basis. One more thing I wanted to do in talking to you in the time that we had was describe how we do the derivation of limits, if there is time. But are there questions first?
I think if possible, Mary Ellen, if you could bring up your presentation again and complete that, I think that would be really
Okay.
good. Thank you.
And I think that someone took control, actually.
Yeah. Can you bring it back up?
I will try. I will try. Okay.
If not.
So while I'm trying to bring it up, I will tell you that I'm not a statistician, but I've had to defend these limits. And so what we do is we array the performance data of how much of the level of effluent resulting from the pollution control technology. And the statisticians derive these plots and curves where we want to account for the variability at a well-operated facility. And the way they do this is we develop a monthly average, but also a daily maximum. And so the daily maximum is just an additional control. We expect people, and
let me bring it up for you, Mary Ellen, if I can. Mm-hmm.
Looks like it might be there. So we expect people to be designing their control technology for a long-term average. And the primary limit in these effluent guidelines is a monthly average. But so that people don't turn off their machine if they're having a good month, there's also a daily max. so that they can never ever exceed a particular number. So most of the numeric limits that I have reviewed do this, and we've described this in court filings. So I probably could find from years past narrative descriptions that I understand as a non-statistician that describe this methodology, and it's been litigated and upheld. So we tend to stick with it so that we know that it's something that we can defend in court in terms of the derivation of limits. So I see that the presentation is up. I don't know if I can, but I guess that was point. Yep, that is in fact that's point 4. So we calculate a monthly average and a daily maximum in terms of each one of these parameters that we regulate, and those parameters represent like all of the toxic pollutants in the waste stream. So next slide, Sally. Mm-hmm. So we propose these regulations and then invite the public to comment on the model technology. I will tell you we had 179,000 comments on that 2015 rule. I know because as one of only 2 lawyers, I'm the manager lawyer, but 2 of us basically reviewed all of those comment responses, every single one of them. So I felt all 179,000 of those comments, and of course some of them you can give a little less energy to than others, but very robust comment process in the United States, and basically criticizing anything possible you can imagine about the regulation. And then we have to respond to those comments, and then a court judges whether those responses are reasonable. So after we promulgate the regulation, they are placed in discharge permits for direct dischargers for people who are sending to a wastewater treatment plant, publicly owned treatment works. They are automatically effective. There's not a permit for those. And then each facility, the direct dischargers particularly, have to monitor and report. They have these things called discharge monitoring reports, and we have a public database called ECHO, ECHO, that reports permitted facilities, what their permit requires, and what they are reporting in terms of their discharges. And EPA, or in the Clean Water Act, members of the public, citizens, can actually take a judicial enforcement action against facilities that are violating their permit limits. So those are the 8 steps. I think we have more slides just in terms of things to consider when establishing BAT, is to consider how is compliance going to be determined. We do this monthly average, daily max. When does the rule apply? Sometimes we give a little bit of time to get up and running. We say it isn't BAT on the date of promulgation, but 18 months after, or in the case of steam electric, because of a lot, we were asking people to make a big jump from one framework to another. We gave them some time when we said that the technology will be available. You need time to finance and install. Will the rule ensure proper operation of maintenance of pollution controls? And that's where, I put in the slide here, this concept of the daily max, because that's just sort of help govern and make sure that people are not just turning off the switch if they were going to meet their monthly average anyway. So what monitoring are you going to require? What reports are you going to ask people to submit? What records are facilities required to keep? Will there be inspections? And does the enforcement agency have enough authority or to request information and inspect sources? In the Clean Water Act, we have a provision, Section 308, that allows us to request information from point sources, and also to, we have really broad inspection authority. I would say we have more limited enforcement resources in terms of people than the public probably is aware of, in terms of how many people are actually, we have the funding to have them actually go out and inspect these facilities. And states also enforce And as I said, citizens can enforce based upon the discharge monitoring reports that are publicly available. So if you have any questions about any of that, I'm happy to take them now.
Mary Ellen, this is Phyllis. I'm just wondering about the state versus the federal requirements and primacy. I know in drinking water, state has primacy with the OK based on a crosswalk. Do you do the same sort of thing with the these limits as well?
So I don't know the drinking water world enough to totally be able to compare, but I can say in the Clean Water Act, 47 states have authority to run the permit program. So 47 of the 50 states are doing the permitting. EPA permits in 3 states and in certain federal facilities and the US territories. So pretty limited direct implementation by EPA. So these rules are being implemented by the states. The permits are reviewed by the regions, especially the major permits, and we have authority to object to a permit. We are not required to object, but we have authority. It's a discretionary act. If we find that a permit does not comply with the Clean Water Act, if we object to a permit and the state doesn't correct the problem, then the permit authority shifts to EPA. So that doesn't happen very often, although like in my docket today, I'm aware of like 2 or 3 permit objections that are going on for the whole, in my area, United States. So that gives you a sense of it is not something that never occurs, but it's a rare occurrence. The regions, the EPA has 10 regional offices and some science labs and other offices. But the 10 regions work closely with the states and develop close relationships with the states and their regions to help them implement the act. And these, we call these plug and play rules. I mean, these are, once they're established, they are supposed to go in the permits. We also, there is a petition process where EPA can receive a petition to withdraw a state program. We've never withdrawn a state program in the Clean Water Act once we've authorized. But those petitions cause us to work with the states to correct any deficiencies in their programs. And then our response to those petitions can be the source of litigation. So we could be challenged on that. So those are serious, matters that we, put a lot of energy into. So these rules, they do occupy the field once we've established them. If we in the regulation, in the preamble, in the description of the regulation, we say these facilities are not covered, these facilities will be done on a best professional judgment basis, then there's a lot of discretion in the state as to what applies there.
Do you see a lot of variability between states?
Not in this space, but in the water quality space, tremendous variability and a lot of transaction costs. And Rob already answered this question, so I didn't re-answer it, but an engineer who was one of the people who first designed this big sewage treatment plant in the Washington, D.C. area called Blue Plains. If you were flying into D.C., you'd see this huge facility. And he walked me around before he retired, and he used to be in Rob's job. He was the division director. And he said to me, Mary Ellen, these rules make people do something different. And I think about the water quality approach as a little bit like a balloon. You can squeeze it on one. I need a mixing zone. I need a variance. I need a compliance schedule. There's a lot of ways to wriggle out of a water quality requirement, or that you haven't proven that this number is necessary, or it isn't me, it's the other guy causing the problem. And so it's very transaction heavy. This is like, once these rules are here, they apply.
Okay, thanks.
Are there any other questions or comments at this point?
It's
Mary
really,
Ellen, maybe in the time that we have available, do you mind going through that example that you had just a little more in depth?
Well, yes, if we go back to the schematic, so for the steam electric pool in 2015, we based our FGD wastewater requirements on chemical precipitation plus biological treatment, for example. And in the Trump administration, as you, I'm sure, are well aware, the hallmark of that administration was we are going to reduce regulatory burden on coal-fired power plants. And so what we did in that regulation was we made it less stringent and created more exemptions. But actually, I will honestly say, we basically made the rule cost about $40 million less nationwide, which is in the scheme of things, not that much of a retrenchment. And what we did for FGD wastewater is the biological treatment was based on one form of biological treatment. There is a cheaper form of biological treatment. Surprise, surprise. This fostered innovation. I think one was high residence time and one's low residence time. And so we were able to basically make the rule cost less and be deregulatory, but actually the low residence time did not perform that much worse than what we had done in 2015. And in fact, for one parameter, the data showed the limit was more stringent. So for two parameters, and I don't want to get them wrong, but the three parameters were arsenic, mercury, and selenium. So for one of the parameters, the 2020 Trump rule actually has a more stringent limit, but for the other two parameters, a less stringent limit. Now we are in the Biden administration, and we have been asked to seriously look at membrane filtration, which would basically be tantamount to zero discharge. And the advantage of membrane filtration is that there are some drinking water contaminants that could be addressed and controlled. And so for facilities that are upstream of drinking water plants, that would be great for those plants if the incoming wastewater did not have those contaminants. The trade association that works for the drinking water facilities sued us on the 2015 rule. They did not sue us on the 2020 rule, though, interestingly. So the 2015 rule was essentially held in abeyance in the court while it was reconsidered by the Trump administration. We issued the Trump rule in October of 2020, and we were sued in a different court of appeals on that, and it's currently in abeyance while we reconsider the rule again. So that's an example of kind of the journey we've been on with flue gas desulfurization. For bottom ash was a very controversial waste stream in 2015 in that I think that the waste stream was more dilute, we're getting less pollutant removals for the amount of money we're spending. And the 2015 rule was based on, I want to say the right technology. It's a mechanical, a zero discharge based on a mechanical drag chain. I might be saying the technology wrong. I probably should have refreshed my recollection on that, but it was essentially zero discharge. And our engineers, in talking with operators, said, boy, you know, this technology, we need to have a little flexibility here to purge some of the wastewater from this waste stream, because what is going on at coal-fired power plants in the United States is they are shutting down the ponds as a result of our hazardous waste law and litigation and court decisions there. And so wastewater is being combined from various parts of the plant using this technology. So in the 2020 Trump rule, we allowed the permit writer to decide on a case-by-case basis whether to allow the discharger to purge certain aspects of this wastewater and discharge as opposed to zero discharge. And that also resulted in a cost savings. So the total cost savings of both of those changes in 2020 was $40 million. So it really essentially was the same rule with a little more flexibility. But we'll be revisiting, that aspect of the rule as well. So the other aspect, just to show you, is the fly ash waste stream was zero discharge for the new sources in the 1982 rule. And when we got to the 2015 rule, we required zero discharge. It wasn't even controversial because 80% of the existing plants were doing zero discharge. So that shows you how laying the groundwork in the new source performance standard kind of created an impetus to people developing a dry handling system that then was not even really controversial or really litigated by the industry. So
We do have a hand up.
sure.
Hi. If I could ask, how do you address the matter of CECs, the chemicals of emerging concern, and especially from pharmaceutical industry, whether it goes into a river or to, and later on is used for irrigation, it can reach vegetables, and while we don't know exactly what is the adverse effect, can you demand AOP as for technology to reduce them?
I don't know the latest in terms of our strategy on contaminants of, pollutants of emerging concern. I don't know if Colleen is still on and if she would be able to address it. Or I don't know
Yes.
if any of my other colleagues from Office of Water could give a more up-to-date report.
Marcus or Colleen?
Yeah, this is Marcus Soberst. I'm a manager over in the Office of Wastewater Management. I'll take a quick stab at answering that. These are challenging topics, obviously with contaminants of emerging concern, of which there are a great many. They are usually things where we have limited knowledge, we have limited analytical capabilities, we have limited knowledge of health effects, effects to aquatic life, etc., and limited knowledge of human health effects, of course, as well as treatment technologies. So with these, what we've been doing, and I can speak perhaps a little bit more about what we're doing with a different class of chemicals, perfluorinated compounds, or PFAS. For that, the agency has recently announced a strategic roadmap to address that. And in our space, what we're looking at is in Rob's shop in OST, a big effort that they have is looking at a number of effluent guidelines to see are there technologies, are there industries that are releasing those? And they'll be looking at that. And then through our shop, we have, actually at Rob's shop as well, they developed a draft analytical method, a single lab validated. Normally we use multi-lab validated methods, but we're going to try to employ that single lab validated method to collect information to inform the development of those guidelines and inform development of potential water quality based approaches as well. And through all of that, we're also really focusing in on source reduction, because a lot of these types of chemicals are going to be difficult to treat. Our treatment technologies are perhaps not well suited for these types of things. And then I think your question also alluded to the issue of water reuse and questions there, and that's where it becomes even more complicated. And I'm sure in the state of Israel, that's a huge issue where you have such a high level of reuse. So as those chemicals are being introduced into our waste stream, to the extent that that's being a circular environment, they're going to be coming back. So we have a lot going on in terms of water reuse in this country. And I think a lot of things point back to, where are those industrial sources coming from, and how can we do a better job of reducing those sources, controlling them? And I'll speak specifically for pharmaceuticals for a little bit. I know that we have controls to say that, you shouldn't be using unspent pharmaceuticals, like pharmaceuticals that are not being used should not be sent down the drain. We discovered in the past that, for instance, nursing homes would often do that, that they would dispose of pharmaceuticals when they were used up, and we've been really trying to prohibit that type of practice. And same thing with drug take-back programs to collect drugs and take them out of the waste streams as well. So we're doing things like that, but you know, these are challenging issues, and we're not necessarily going to fully resolve, you know, therapeutic uses of pharmaceuticals that are then entering our waste streams is a huge challenge. So hopefully that was at least partially successful answer for your question.
Thank you, Marcus. And I know we are at time, so thank you again, Mary Ellen, for your excellent presentation, and Rob Wood, and thank you, Marcus, also, and others who helped to answer the questions. I want to continue to thank my agency partners in this webinar series, Teresa Kuklinski from our Office of International and Tribal Affairs, and Maria Lopez Carbo from our Office of Wastewater Management. And of course, I want to thank Phyllis Posey for her partnership and guidance and her willingness to really help distribute these materials. Our next webinar on the NPDES permitting program will be on November the 18th. Thank you for your participation today. And like before, we will be posting the webinar and making it available to participants who could not attend, or those who would like to review the materials again. Thank you very much for your time. Have a great afternoon.
Thank you very much.
Thank you.
Thank you.
Thank you very much.
Thank you.
Thank you so much.
Thank you.
Thank you.